Hello and welcome back. Let's continue in 3.6 talking about quadratic functions in general form. On problem 3, it asks us to find the vertex, axis of symmetry, x-intercepts, and y-intercepts of this function so that we'll be able to graph it. And make sure when we graph our function that we also label the function. Let's start off with finding the x-intercepts. So to find the x-intercept, remember we said we're going to let y equal 0 and then solve for x. But we look at this form, we have h of x equals negative x squared minus 8x minus 15. Now when we talked about finding these x-intercepts before, we had it in factored form. We talked about factoring in 3.5, so let's go ahead and factor this so that we can find our x-intercepts that way. So I'm going to go ahead and call h of x y and write this as y equals negative x squared minus 8x minus 15. And then I can factor out a negative 1, which will leave me x squared plus 8x plus 15. And now we want to factor that trinomial. And the reason why I factored out that negative 1, it makes it a lot easier to factor this if our leading term is positive. So if you ever have a negative there, factor it out first and it'll make the rest of the factoring a lot easier. Okay, so now we're thinking to ourselves, what two numbers do I know of that will multiply to be 15 that add to be 8? Well, we know 3 times 5 is 15, and if 3 plus 5 is 8. So we're going to have x plus 3 and x plus 5. Make sure that you are really getting used to your factoring and practicing a lot. You're going to be using factoring so much. And so if you're struggling still with factoring, find some help with it. All right, now that we have it in factored form, let's go ahead and do what we had here. So we're going to let y equal 0. So in place of that h of x, which I called y, I'm going to have 0 equals, and then I'm going to write it in factored form. And now we're going to use the zero product property to help us find our x-intercepts. Now remember, if I put 0 equal to negative 1, that's just a nonsense statement, and there's no x value to solve for there. So we're not going to put that factor equal to 0, but let's go ahead and do the other two. So x plus 3 equals 0, and x plus 5 equals 0. Let's subtract the 3 over and get x equals negative 3. Subtract the 5 over and get x equals negative 5. And now make sure you always write these x-intercepts as ordered pairs. So my first one, right, we said we're going to let y equal 0, and then we found x to be negative 3. And then on the other one, same thing, y is 0, and our other x value was negative 5. Right, so I came up with those two values, those two x-intercepts. All right, let's talk about the axis of symmetry now. All right, there's a couple of different ways that we could go about finding this axis of symmetry. Since we know what those x-intercepts are, we talked about when it was in intercept form, that we could add those two x values together and divide by 2, because we need to find the average of those x values. So I could do negative 3 plus negative 5, all divided by 2, or that's negative 8 over 2, which simplifies to be negative 4. So that is my axis of symmetry. That is the line that the parabola is halfway in between, that if you folded it over, it would be 1/2 exactly on the other half. Right, but the other way that you could do this is you could use the vertex formula, which was talked about above, meaning use that x equals -b over 2a. Now we just need the x part of that because that is going to tell us our x value of our vertex, but that x value of our vertex also indicates what our axis of symmetry needs to be. All right, let's look and see. We're going to get the same thing here, but let's check it out. So x equals, now remember I'm going back up here to my A, B, and C. So we can see the b value here is -8, but we want to do the opposite of -8, which is +8. And then 2 times -1 is the a value. So I get x equals 8 over -2, or x equals -4. Both ways work. You can pick which way you like best. We might not always know our x-intercepts, but when we do, it's usually fastest to go this way, but both ways will work. Now let's look at finding the vertex. So for the vertex, this x value that I found here for my axis of symmetry, that line of symmetry, also is my x value in my vertex. All right, so now we need to find our y value of this, that second coordinate, and we can do that by plugging it back in to our original equation. So y equals negative, and then in place of my x, I'm going to put -4 all squared minus 8 times -4 minus 15. So -4 squared is 16, but then we need to multiply it by a -1. Remember your order of operations, square it, then multiply it by the -1, so that's -16. -8 times -4, +32. Then bring down that -15. -16 plus 32 is +16. -15 is 1. Y equals 1. That is our other part of our vertex that we need. Let's find our y-intercept now, and then we'll be able to graph those points. Again, let's start off with the equation. Y equals -x squared minus 8x minus 15. So with our y-intercept, we let x equal 0 and solve for y. So on this, if we let x be 0, go ahead and put 0 in place of both of my x's there. And I see, oh, that first term just goes to 0. 0 squared is 0. 0 times -1 is still 0. 8 times 0 is 0. So those two terms just zero out, and we're left with -15. Y equals -15. So when it's in this general form, it's easiest to find that y-intercept. Let's go ahead and write this down as the ordered pair as well. We said x was 0, and when x was 0, y is -15. Let's take a look and see what this graph looks like. And voila, here is our graph. Let's check out the different parts of these. So we found our x-intercepts, so make sure you graph those, your vertex, also your y-intercept, and then our axis of symmetry is x equals -4. Now we didn't find this point over here, but I wanted to point out that you can find it through symmetry. If I look to see that, how far away is the center from our point over here, and it's 4 places. So if I go 4 places over here to the left, then I'll get to another point on the graph. So use that symmetry to your advantage. It can be really helpful in graphing these.